Good afternoon, everyone. My name is Christian Bolden, and together with my teammates Mike Davis, Phil Weinberg, and Sid, we're going to present you the BottomLine game today. We're going to tell you a few things about what the game does and the artificial intelligence involved in the game. So, like our friends Mike said, let's cut to the chase and talk about the overview a little bit. What this game basically is a combination of Tetris and Sudoku. The ultimate goal is to beat rows and columns with number blocks, such that these numbers on the column on a row will add to a certain value. The main challenge is to place the numbers such that they form rows or columns that to a certain value, and you want to do this as soon as possible on the highest speed in order to get the most points available. So in order to play the bottom line, it's actually pretty simple. You just use arrows to guide falling blocks on canvas. The canvas displays the assignment at the start of the page and the sum for each row and column. That assignment will change throughout the duration of the game and will allow the user to be more or less challenged based on his skill set. The blocks involved into the game are mainly positive numbers from 1 to 9, negative numbers from 1 to 9, or multipliers of 2, 3, and 4. Moving on to the artificial intelligence. This game uses statistics and algorithms in order to change the game difficulty level. We have a number of inputs that are being updated constantly throughout the game at runtime. The statistics involve vertical matches, horizontal matches, the average time between matches that a user performs, number of blocks on field, the maximum column height, which can be more or less important throughout the game. For example, if at one portion of your game your column height will be very close to the top, obviously that will be more relevant than at the beginning of the game when it's maybe just a few blocks. And because we talked about flow throughout the class, I'd like to say how the artificial intelligence keeps the users into the flow of the game. As you guys can see, some of the actions performed by the artificial intelligence based on the statistics would be to activate or deactivate the suggested move, to adjust the block of the falling speed, to activate, deactivate the next block display in order to allow the user to see, what the next block will be or not, and of course to adjust the multiplier occurrence probability. If you're going to play at an easier level, the multipliers will not show up as often, and of course the player will have less calculations to do. Now I'm going to ask Phil to tell you a few things about the actual implementation of the artificial intelligence.
Thank you, Christian. Okay, I'm sure you're very interested in how this thing works on the last day of school. So, we have an array of weights and an array of inputs. You can see our inputs here and our weights here. What's interesting to note is that these weights were pretty much pulled out of thin air. I have enough time to test it, and since, Monday was the first time any serious amount of users came and actually played the game, I wasn't aware of what would be the result of using those weights. What is important to note is that this weight right here, the negative 0.4, is in fact the only negative number there. So take a brief look at this, the next slide. What does that negative 0.4 actually mean for the long-term implication of this game? So in the long term, total matches keep going up and up as they make more and more matches. And assuming everything else doesn't change too drastically over the game itself, which is quite an assumption. If total matches increases without bound, and it's only -1, what does it say about the classification? I'm assuming most of you don't know this. So Stephen, thank you. The answer? 7. Close. Actually, the problem is that since total matches increases throughout the entire game and isn't bounded by anything, and it's a negative number, classification will tend in the long term towards a negative number. And since, as you can see here, the lower the classification is, the better the game rates your player. So the classification is really just a floating point number. But I turned that, and based upon these ranges, which are kind of like guesswork, I assigned them an actual player by adjusting the outputs accordingly. So if they're on the long term, the game tends to the negative. That means in the long term, everyone becomes really good at the end. Even if it's not true, the game will still consider them to be better as time progresses. And this will result in them, well, more or less losing in the end, regardless. Which is really our point. You don't want them to play forever and ever. You want them to keep getting challenge to challenge, or if they aren't able to meet the challenge, eventually the game will conclude and they can go on their day. Or play again, who knows. So there's various classifications. I'm only using really 5. Yeah, only 5. I could have divided into more, but you have to remember that, as you'll see here, we only have a few outputs, and most of these outputs are very discrete. For example, we've got assignment difficulty, which is really depends on how your assignments are generated, which is the multiple of thing that many of you have seen when actually the game is being played. Another key output that's pretty much not variable at all is your block fall speed. If it's at 0, it's not moving at all. It's hovering there, matrix-like. Or if it's at 4 or 5, it's actually rather fast. It's kind of hard for a human to see and react that quickly. So when we have considered that at least 2 of these are just pure booleans, you really can't just have a classification and have that drive the outputs directly. You have to have this classification, as you see back here. And since the classification, because the outputs have a very limited range, it's best to do something like this. Though I suppose there are other ways to do it. Additionally, this classification is actually averaged the past 20 classifications. This helps reduce the effect of temporary things like you're getting a match, which somewhat changes the various variables. So you're recently get a match, turns without a match, becomes 0, maximum height will usually disappear, you lose 2 blocks, and another standard jolt in the data. So you're sampling it, kind of smooths that out. Any questions before we go to the demo?
Initial classification. The initial classification.
Ah, okay. Yes, actually I think that's one of my problems here. Huh. Okay. Either way, must have lost it somewhere in the internets. The problem is that initially, if you're sampling in the past 20 time slots, initially you don't have anything to sample in the past. So what we do is when the game starts up, it prompts you for initial difficulty level. Let's say easy to insane. Depending on that, we'll actually fill your average classification. And insane will start you as a rank 0 player, which is pretty good. Whereas easy will start you as a rank 50 player. I'm sure you're buzzing with questions. No?
Mine's going.
Really?
How much money do you expect to make on the market?
Conservatively, $2,000 to $3,000. The long-term capitalization, it could vary.
So I want to know.
You're an investor?
Yeah.
I'll give you my card later.
Question.
How many sequels do you have in the pipeline?
Well, BottomLine 2, Revenge of the Blocks, is actually a thrilling sequel featuring the main character who's now returned from the grave with a vengeance. Yeah, the next sequel is not planned yet. Some production.
So with the kind of playtesting that was done on Monday, were there any kind of issues that you guys discovered with your algorithm, or were things kind of scaling properly, or what?
Well, some of us deserted me, so I was all alone. But actually, the people that I did see were doing actually fairly well. People actually engrossed, which I found to be somewhat fascinating. How it actually performed? The problem was that, going way back, if you can even do that, it's only sampled for 20 turns. And initially, all these values start very small, because you have a very few boxes that feel a very small column height. What this means that after those 20 turns and your initial values are no longer all there, it'll quickly bring you down to a more advanced player. And people, when they saw this initially, and are still uncertain about it, are usually a bit confused. Though some of them seem to take it in stride and react to the challenge.
Did you guys consider using, because you've had the AI class, using like Samuel's approach to try and learn and come up with what would be an acceptable set of parameters for the equation?
Who was the checkers person?
Yeah.
Okay.
Do you remember
Well, I certainly considered it. I considered many ways to get these weights more intelligently instead of guessing them. But then I also considered the fact that, well, I thought the weights themselves were somewhat flexible, and there probably are dozens of combinations of weights that would result in a playable game. Because remember, our concern here is not, the best one. We just care about one that makes the most fun, that's at least playable. And there are probably an infinite number of combinations of these weights that will really result in a game that is playable, adaptive, and somewhat enjoyable to play.
We actually wanted to change the weights originally, because the thought process was like how tall the blocks are, how many number of blocks are on the field at a time. If there's a lot more blocks on the field, you should probably weigh them a little bit more than if there's no blocks on the field as far as the specification of the player. But Phil pointed out that that would get very tricky as far as...
Right, so if you're changing weights, this problem turns from like a simple feedback to a much more complicated feedback problem. Additionally, if the weights themselves change, you probably have to specify how the weights are weighted, the change of the weights are weighted themselves, which opens up another layer of weights, and it pretty soon becomes rather complicated.
Also, to deal with the initialization problem of initializing your classification of a player, we wanted to save the weights, what classification a player was last at, because we implemented the enter your name for the high scores pretty late, but once we did that, we needed to do to keep track of your classification. But again, Phil pointed out that if we save the weights that they lost at and we load them up at the same weights that they lost at, then it's probably not going to be fun for them because they're at the exact spot. I guess we could have did it at maybe a history -2 or something. We got the weights right before they lost. We just left it set.
Okay. Any other questions from people?
Do you notice like a big change in the amount of time it took for different players to achieve the different levels? Like, I mean, was it working on that end? Like, some people might take 30 seconds to achieve the next level, and some people have to take 2-3 minutes.
So
Right, it kind of slow, but there were some players who actually really got into the flow of the game, if I use that buzzword, and the game was kind of revolving around them. Other players were still, let me put this nicely, not too good at the maths. And all those falling blocks just confused them, and even allowing them to try, it couldn't make it that easy for them.
But there were a few marketing majors over there, I know they had some difficulties playing the game, but...
Any others? Okay, thank you guys.